Alright guys, in this video we're going to be introducing partial fraction decomposition. So before we do that, let's cover this integral real quickly. We have the integral of 1 over x minus 2 plus 1 over x plus 1. If you're not familiar with this type of integral, we can tackle it with a quick u-substitution. And again, let's put that there. We're going to write this a little more generally as 1 over x plus a. Because if we can get a little rule for this, we can keep using it over and over. Okay. I'm going to let u equal x plus a, because then du is equal to dx. And well, that's really straightforward. We can just remove the dx, place it with a tu. We're going to have 1 over u du, which you should recognize as ln u plus c. And once we substitute back in, we're going to have that integrals of this form are equal to ln x plus a plus c. Okay, and using that rule, that means this is going to be equal to ln of x minus 2 plus ln x plus 1 plus c. All right. Using this simple example, let's see how we can do the next one. We have the integral of 1 over x minus 2 times x plus 1. So if we had it written like 3 over x minus 2 plus 1 over x plus 1, we could do that very easily using the previous rule. But here, what happens is that it's not. We don't know what that value at the top or the other value there we're going to be. So what we do is just let them be a and b. Okay. So one of them has to be x minus 2, and the other one has to be x plus 1 for the denominator. So we're going to have some a divided by x minus 2 plus some b that we don't know yet, over x plus 1. And that's equal to 1 over x minus 2, x plus 1. We're not doing any integration yet. We're simply rewriting this expression so that we can use the rule from above. Okay. And what we can do now is multiply both sides by this expression. Let's do it intelligently so we save time. So for this one, if we were to multiply by this expression, these x minus 2's would cancel, leaving only x plus 1. And likewise for the b. So we're going to have a times x plus 1 plus b times x minus 2. And again, since we multiply by this expression, this is going to be equal to 1. Okay. And to solve this now, what we can do is cancel out the a and b one at a time. And to do that, let's just substitute in some x values. So for the first case, if x is equal to -1, we're going to have a times 0 plus b times -3 is equal to 1. The a cancels, and we're left with -b times 3 is equal to 1. In other words, b is equal to -1/3. Okay, so now we know the value of b, and if we plug in the other x value here, that would make it 0, we can find the a value. So if x is equal to 2, we're going to have, okay, plug in 2 here, that's going to be 3a plus 0 is equal to 1. So a is equal to 1/3. So using this expression from the top, let's rewrite that. So we're going to have 1/3 over, what was it, x minus 2 plus, and the b was negative 1 over 3 divided by x plus 1. And if we simply take these values to the side, then we can use our rule as normal. So I'm just going to be integral 1/3 times 1 over x minus 2 dx minus integral of 1/3 1 over x plus 1. And since we have them of the form 1 over something, we can use our rule now, which be 1/3 ln x minus 2 minus 1/3 ln x plus 1. Okay, so that would be that integral. And we can move on to the next one. We have the integral of 1 over x squared minus 5x plus 6. Let's try to do something similar to the previous problem. So I'm going to factor this bottom first, and that's going to turn into integral of 1 over x minus 3 x minus 2 dx. And let's make up some coefficients. So we have a over x minus 3 plus b over x minus 2 is equal to the original expression, which is 1 over x minus 3 x minus 2. All right, doing the same as last time, multiplying by this giant denominator, we're going to get that a times x minus 2 plus b x minus 3 is equal to 1. If we do the same thing as last time with our cases, let's try x equals 2. We're going to get that negative b is equal to 1, implying that b is equal to negative 1. And for the next case, where x is equal to 3, we can do is a is equal to 1, since this would be b times 0 and 3 minus 1. Here, sorry, 3 minus 2 is 1 here. Okay, so now that we have our values, we can rewrite the original integral. We're going to have, okay, a is equal to 1, so we put that in. So that guy, 1 over x minus 3 plus negative 1 over x minus 2 dx. That's simply going to be ln of x minus 3 plus minus ln of x minus 2. Let's see. Okay, and this is one way to write it, but here, I wrote it here with the plus sign and a minus sign to show you something later. If we move the plus sign here, we can also rewrite this as ln of x minus 3 divided by x minus 2 by logarithm properties. And if we do the plus sign instead, then we could bring this negative to the inside, and multiply using logarithm properties, but that would be an inconvenient way of writing it. All right, so that's our answer there. Moving on to the next one. This is going to be our final one. All right, so we have the integral of 3x plus 1 divided by the quantity x minus 1 squared times x plus 2. This one's going to be a little more tricky since we have a quadratic term here in the denominator, but nonetheless, it's the same process. Okay, so I'm gonna begin with a over x minus 1 squared. And this is what changes. When you have a power here, what you have to do is also make a term for all the ones below that power. So what does that mean? We're also going to include b divided by simply x minus 1. If it had been x minus 1 cubed, we would have done cubed, squared, and then to the power of 1. Okay. And finally, c over x plus 2. It's all equal to 3x plus 1 divided by x minus 1 squared times x plus 2. Okay, multiplying by this denominator, we're going to get that a times x plus 2. Since if you multiply this to x minus 1 squared, cancel, plus b x minus 1 x plus 2 plus c times x minus 1 squared is equal to 3x plus 1. Okay, again, we're going to begin by trying some smart x values. One of them being x minus 2 here. Let's try that. So if x is equal to minus 2, that first a cancels, that b cancels, and now it's just a c. So minus 2 minus 1 is going to be 3, negative squared, so you get 9. 9c is equal to, plugging negative 2, we're going to have negative 6 plus 1, which is negative 5. So c is equal to negative 5 over 9. Let's do the same thing for 1 right here. And here I'm just writing x to indicate that it cancels out. Okay, if we do 1 instead, we're going to have 1 plus 2, 3a, plus some cancellation, doesn't matter. And then substitute x is equal to 1, it's equal to 4. So therefore, a is equal to 4/3. And now you may be asking, what about this one in the middle? There's not really anything we can do to cancel that one out. So for that one, we have to think of the coefficients here. I'm going to begin by adding here plus 0x squared. And the reason for that is if we expand on the left side, we combine like terms for an x squared, and the coefficients here on the left of the x squared term should match whatever's on the right side. Okay, so let's do just that. For the x squared term, we know that the guy on the left here is not going to be relevant since it only provides an x and a 2. The ones that would be relevant are b and the c. So let's do those real quick. We're going to have b times x squared minus x plus 2x. So plus x minus 2 plus x minus 1 squared. It's going to be x squared minus 2x plus 1. And when we take the x squared term out of all these, the coefficient of it is going to be b plus c times x squared. Out of this whole expression, the x squared term is going to be this guy. And that's equal to whatever was on the right side, which is 0 x squared. That implies that b plus c is equal to 0. So if c is equal to negative 5 over 9, that means b is equal to 5 over 9. Okay, and now that we know the a, b, and c values, we can bring them back here and integrate as normal. We can write the integral again. So I'm going to break it up into 3 little parts by properties of integrals. Okay, so we're going to have a over something. We're going to agree that's a times something. So we're going to have the a value, which is 4/3, times the integral of 1 over x minus 1 squared dx plus the b integral. Okay, factor the b to the front since it's just a constant, plus 5 over 9 integral of 1 over x minus 1 dx. And now for the c here, we're going to have minus 5 over 9 integral of 1 over, what is x plus 2? Yeah. It's 2 dx. We can do the ones on the right pretty easily. But for the first one, we're going to do a little u-substitution. Okay, so for this guy, let u equal x minus 1, because then du is equal to just dx, which is pretty simple to deal with. Okay, so rewriting that, we're going to have 4/3 times the integral of 1 over u squared du is going to be equal to 4/3 u to the negative 1 divided by negative 1 by the reverse power rule plus c. And substituting in u, I'm going to bring this negative to the front. Negative 4/3 times 1 over x minus 1 is the first guy. And then we can just tack on these next ones. So since I'm going to add them anyway, I'm going to leave the c for later. Okay. Plus 5 over 9 ln x minus 1, and then minus 5 over 9 ln x plus 2, and finally plus c. That is our integral from there. That's a pretty long one, but it is a pretty repetitive process. So once you get the hang of it, it's going to be second nature, and you'll be able to get this pretty quickly.